So in this example we would like to find the output voltage in terms of the input voltage V1 and V2 in this circuit, and all these resistors have the value of R. Right, I cannot identify any building blocks to use shortcuts to solve these circuits. So what I need to do is that I need to write a number of helpful KCLs and combine them to find the output voltage. So this node is an OpAmp input. I can write a KCL for. The same here. This node I cannot write a KCL, or it's not helpful, because then I will have to use this current, output current of this OpAmp, which is unknown. So this KCL at here doesn't help. The same here, I cannot write the KCL there. However, the KCL here would help, and also the KCL at this node would help too. So let me label these currents: I1, I2, I3, I4, I5, I6, and I7. And I also noticed that the voltage of this positive input of the OpAmp is V1, so the voltage of this node is V1 too, and for the same reason the voltage of this node is V2. So let's call this Vx and this Vy and this voltage Vz. Alright, so I will have KCL for node 1, node 2, node 3, node 4. I'm sorry, not node 4, because not 3 and 4, because these are output nodes of the OpAmp, so they don't help. Node 5 and node 6 here. So I will write, this case is 1, 2, 5 and 6. So the KCL for node 1 is I1 plus I2 equals 0, or you can say I1 is leaving this node, so minus I1 minus I2 equals 0, which is the same thing. KCL for 2, I2 enters, I3 leaves, so I2 minus I3 equals 0. At this node number 5, I4 enters, I5 leaves, and this current going into the OpAmp is 0. At this node, at node 6, I6 enters, I7 leaves. So these are the KCLs that might help me find the output voltage. So the next step is to express all these currents in terms of node voltages. I1 is this current going from this node up to this node. So it's voltage V1 minus Vx over R. I2 is V1 minus V2 over R. And I noticed that for all these currents I will have to divide the voltage difference by R, and eventually I can multiply all equations by R and get rid of all R. So let's not write that R to begin with. So I know there is a divided by R, but because they all have that, I can cancel all of them. So for the second node, V1 minus V2 is I2 minus I3. I3 is V2 minus V1 over R, V2 minus V1. And I have an additional negative minus V2 plus Vy. It is V2 minus Vy with this negative sign. At node 5, I4 minus I5, Vy minus Vz. Minus I5. I5 itself is V2 over R. So it would be minus V2. And finally the KCL at 6 here, I6 is Vx minus. What is the voltage at this node? Because this is called labeled V2 and this is the positive input of this OpAmp, this is the negative input of the same OpAmp. So this voltage is V2, 2. So I6 is Vx minus V2 minus I7. I7 is V at this node minus the V at this node over R. So it's V2. So this is not V2, I'm sorry, this is Vz. So let me clarify, this is Vz. And this is Vz. For this equation, I4 is Vy minus Vz minus Vz. So I6 is Vx minus Vz here. And I7 is Vz minus V0 over R, Vz minus V0, minus Vz plus V0 because of this negative sign. So we have 4 equations here. So I need to, in these equations V1 and V2 are known. So Vx is unknown and I don't need that. Vy is an unknown. Vy and Vz are unknowns. Vx, Vz, these are also unknowns that I need to eliminate all this and eventually have an expression in terms of V0 and V1 and V2. Alright, so from the first equation I see that Vx is 2V1 minus V2. From the second equation, Vy is 2V2 minus V1. From the third equation, Vz is Vy. Vz is Vy divided by 2. From this equation, V0 is 2Vz minus Vx. Alright, so 2Vz is Vy. From this equation, 2Vz here is Vy minus Vx. Vy itself is 2V2 minus V1. Vx is 2V1 minus V2. So my V0 will be 2V2 here minus V2 is 3V2 minus V1 minus 2V1 minus 3V1. So the expression for the output voltage in terms of V1 and V2 is 3V2 minus 3V1, and barring any mistakes here, that would be the solution to this problem.